semiconductor is a material which has an electrical conductivity value falling between that of a conductor, such as copper, and an insulator, such as glass. They are classified by the fully occupied valence band and unoccupied conduction band, with a small band gap in between these two bands. Here, the energy increases while moving from the valence band to the conduction band. The energy gap between the two bands is represented by Eg. Energy gap in silicon is 1.1 eV. Direct bandgap semiconductor. In a direct bandgap semiconductor, the top of the valence band and the bottom of the conduction band occur at the same value of momentum, as in the schematic. In a direct bandgap, DBG, semiconductor, the maximum energy level of the valence band aligns with the minimum energy level of the conduction band, with respect to momentum. Direct recombination happens when the electron in the conduction band meets the hole in the valence band. They combine, and energy is released. In a DBG semiconductor, a direct recombination takes place with the release of the energy equal to the energy difference between the recombining particles. That is, given by EC minus EV, which is equal to 1.1 eV, in silicon. Indirect bandgap semiconductor. In an indirect bandgap semiconductor, the maximum energy of the valence band occurs at a different value of momentum to the minimum in the conduction band energy, as shown in the schematic. In an indirect bandgap semiconductor, the maximum energy level of the valence band does not align with the minimum energy level of the conduction band, with respect to momentum. In indirect recombination in semiconductors, the process involves an additional step compared to direct recombination. Instead of directly recombining with the hole, the excited electron scatters with other electrons, phonons, lattice vibrations, or impurities present in the material. This scattering can happen due to thermal energy or impurity interactions. After scattering, the electron changes its momentum and energy. It eventually encounters a hole in the valence band, which it can recombine with. The energy released upon recombination is equal to the energy difference between the conduction band and the valence band, which is also known as the band gap energy, that is, EC minus EV.